This is doing inversion. You have this transformation that you're supposed to accomplish. You're doing the work. But when you're actually analyzing, what you're doing is you're saying, here are two sets, and I want to know how they're related in the first place. I want to know, do I need transposition or do I need inversion? And that's what we need to be able to recognize. So what we'll do is we'll find the intervals within a set and look at their properties. Try this. At the very bottom it says, are the following two sets related by inversion? Let's answer that question by starting with the intervals. Mark the intervals between those notes, and don't forget the wraparound interval. Are these two sets in normal form?
Yeah.
Yeah, how do you know? Because normal form is as compact as you can make it. The overall span is small. Small as possible. So yes, these are already in normal form. Now, you're saying that they are flipped. How can I see that?
Because, what's that? Because I turn them into the note in the clock face.
Yes.
That F first becomes FAB. That the interval relationship between them is 3 and 1. The second is 1 and 3.
But if you're doing it in semitones, F to A is a major third. Or
F semitones. So 6 and no 5.
Well, a major third is 2 whole steps. If you like to think of it that way. So 2 plus 2 is 4.
Okay, 4.
See how you can get to the intervals? The semitone
yes,
quickly?
yes, yeah.
Okay, and then this is just a step, whole step, which is 2. Yeah, and that's A to B if you like. Although you could spell them anyway, and that's why we do it with numbers, because then you avoid the whole issue of enharmonic equivalence. You just show one representation and you don't have to worry about spelling. But okay, so here I see an interval pattern. If I start here, I'm starting with the smallest interval as we have done before for set class. If I start here and go this way, I get 2, 4. But in this one, I have to start here and go that way to get the 2, 4. Now, to connect with the visual image that you have in front of you there, these clock face pictures, let's do that on the board too for each one of these. Okay, so we have 5 o'clock, 9 o'clock, and 11 o'clock. But this one over here is 7, 9, and 1. You can see the 2s. You can see the 6, the big interval here. 6, when they're opposite one another. 6. 1, 2, 3, 4 on this side, 4 over here. So if we go this way, we'll get, oops, I don't want to go that way. I do want 2 first, but I'm going to avoid the 6. Here's my 6, I want to avoid it, go that way. If I want 2, 4, 6, I need to read this way, starting here, 2, 4, 6. And I'll experience the same intervals, but if I'm going this way, it's actually -2 and -4 and -6 because I'm going this way. Here, they're positive because clockwise is positive. Go back in time, so to speak, minus. Forward in time, plus. Okay. So how can I get this one to look like that one? How can I turn this into that?
Mhm.
I have to flip that. Yeah, I have to invert. Good. So when I see the same interval pattern, but read in opposite directions, I need inversion. If I can read off the same pattern in the same direction, then I need transposition.
Can this also be a transposition though?
You
T
can try
minus
it.
4.
You take this and you just keep spinning it around and see if you can line it up with this one. If I try and get this, so if I try and get this to line up, maybe I'll try and get the 4. So go over here. Ah, shoot. See, I get a note over there. I cannot get this one unless I take it and I flip it over. Can you see that?
Well, I meant minus instead of going clockwise, going counterclockwise.
Yes, going counterclockwise, we'll see that they are the same. But that means we had to invert.
Okay.
Invert means you flip it. Now, if I wanted to get from here to here, and I wanted to specify what that was, I have to find a way, I have to know what flips into what. And that's a trick. And so I'm going to give you a quick way to get at that. What becomes what?
Yeah.
You already have the referential pitch class, and you know that that interval pattern 2, 4, 6 departs from it. So those two notes must invert one into the other. Follow me? If I just pick any old note here and say, oh yeah, those are inversion, I can't be sure of that at all. I need to know that those two notes are analogous, that they have the same role to play in their two sets. You see what I mean by that? You can't just pick any two notes and say, that became that. No, you need to be sure about that. So pick the referential pitch class in terms of set class thinking. Pick the referential pitch class here and the referential pitch class here. In other words, 2 and 7. 2. E and 7. There's something about Thursday nights. You know what? I just the math does not work anymore. It gives up. Goes on break. All right. So I know that those two notes. If I can figure out how this inverts into this, the rest are going to follow suit.
Mhm.
That's what I need to know. Okay, so let's take those two. If I invert E, so I do this to it, I invert E, what will happen to it? What's the result of inverting it? 11 becomes 1. Okay, but wait a minute, we need it to become 7, so what am I going to have to do next?
Spin
T6.
it to
Yes, spin it how much?
6.
Yeah, I need to go 6, so I'm going to go T6I, and that will add 6 to here and produce 7. Yay, that's what I want. I want 11 to become 7. So if I do this, I'm asserting, if I do T6I to this whole mess, I'll get that mess. Yay. Let's see if it works though. Don't rejoice yet. We don't know. We gotta check it out. So 5, 9, 11. That's our original set. We're gonna do just like we did over there. Invert it. Okay. Inversion of that is 7, 3, 1. With me so far? These are summing to 12. You can also think of 5 becomes negative 5, which is 7. If you like, if you want to visualize, you can do that too. Okay, but now we need to do something else. We need to transpose by 6. So here we're going to go T6. I could do this as arrows. I'm doing this to get that, and now I'm doing this to get something new. All right, so T6 of 7 is 1. You want to do the math there? 6 plus 7 is 13. Do you know military time?
24.
Yeah, you go up to 24, but 13 is 1 past 12, right? So,
Okay.
so you can minus. If you like to do it longhand, you do this. This is called mod 12. It's clock face arithmetic. You don't have numbers bigger than 12. You don't even have 12. You have 0. 0 through 11. So what you do is if you end up with a big number that's bigger than then it's 12 or bigger, then we'll subtract 12 out from it. So this was 13, and we need to turn it in, to put it on the clock face, we have to get 12 out of there, take away a 12-hour period, and we end up with 1. Try it. You go 12, and we need 13, you go 1 more, right? So that's, if you want to work it out carefully, that's it. All right, so T6 of 7 produces 1. What if I T6 3?
9,
9, and then
7.
7. Okay, did it work?
Mhm.
Yay, it worked. Now, all that depended on us picking the right 2 pitch classes. We had to know that this became that, and that all of them would follow suit. We have to know that those 2 notes are truly analogous to one another. They are in the same position within their sets. Well, that's what referential pitch classes are. They're a way to solidify one note and say, hey, that's where I can build this interval pattern from. And if I can build that interval pattern, same interval pattern, from those notes in both sets, I'm good. That will work. I know that all the other pitch classes will follow suit. It's a big step. We have to know that. Okay, let's try a couple in a real musical example now. So you want to be able to recognize, just from the intervals, if you need to use inversion or if you need to use transposition. How will you know that? You'll put the set in scalar form, you'll produce the intervals, and then you'll compare the intervals in the 2 sets, and you'll say, they're identical. I can read them off in the same direction. I get the same pattern. What will I use?
Oh, if it's the same pattern, then transposition.
Transposition, because transposition just spins it and keeps those intervals the same. But if I see that one has to be read one way and one the other, opposite directions, what do I use?
Inversion.
Inversion.